Hi, my name is Ananya Ipsita and I'm going to present the paper towards modeling of virtual reality welding simulators to promote accessible and scalable training. My co-authors in the paper are Levi Erickson, Yangzi, Joey Huang, Alexa Bushinski, Sraven Saradhi, Anna Villanueva, Kylie Peppler, Thomas Redick, and Karthik Ramani. There is presently a substantial deficit in skilled welders. This is largely driven by an aging workforce and growing industrial demand. Conventional welding training methods are unable to meet this demand due to high cost and time, geographic constraints, and rigid scheduling. Filler metal, gas, and other consumables increase costs. Equipment availability is also constrained, which limits the number of students that can be trained at the same time. Therefore, there arises the need to introduce more accessible and scalable methods of training to enable faster skilling of welders. There is strong evidence that supplementing traditional in-person welding training with VR for novice welders is effective. However, there are major restrictions to current VR systems, for example, high cost, complex hardware, and limited content. The contribution of the work lies in the design and development of the training system to make welding training accessible to end users. We present VR Weld Learner, a system design that systematically breaks down welding and provides a learning rationale and taxonomy extracted using the backward design approach in learning sciences. We provide a design framework consisting of structured learning modules to achieve a low-cost and widely scalable virtual metal inert gas welding training. Finally, we conduct a user study with 24 welding novices to validate the system's usability and evaluate user experience and performance using a minimum viable prototype. We adopted the backward design model to design the learning content for VR Well Learner. As a first step, we worked with the welding training experts to first identify the learning outcomes and then backward design the learning objectives and evaluation strategies for assessing learners' skills. Next, the instruction was designed in form of self-directed learning modules with guided activities, practice sessions, and assessments to enable learners gain proficiency in an organized manner. A set of design guidelines were developed to act as building blocks for developing the learning activities. The virtual learning activities were designed in the form of interactive video tutorials, guided activities, and task demonstrations to provide sufficient information to users to proceed correctly. Careful consideration has been taken to evaluate and check the user's performance and provide feedback at necessary steps before moving on to the next sessions. As a part of the learning content, we provide an engaging and low-cost alternative for visual haptic guidance associated with carrying the physical welding gun while performing virtual simulations. By using 360 video rendering, the system can transfer worksite into a virtual platform for helping in the transition to manufacturing workplaces and enable personalization of the training environment in VR. The virtual learning content was designed in a structured format to help users learn the concepts of safety, machine setup, maintenance, and welding. The first three modules introduce the non-welding content to novices and acts as an essential precursor to the welding training. Adding this content in VR results in a more rounded and full-fledged form of training for novices. Having been introduced to the tools and functions in the welding settings, novices can more confidently enter the welding training modules. In order to evaluate the accessibility, effectiveness, and engagement of the system, three lessons were selected to develop a minimum viable prototype for the user study. First, safety PPE was introduced to acclimate the user to the scene and implement an interactive comprehension test. Second, the wire change lesson was implemented in such a way that it could provide detailed information about the correct steps in sequence needed to perform a wire change in a welding machine with guided activities and interactive video tutorials. Third, in the weld joint exercise, using the feedback system, users can virtually weld a T-joint in a horizontal position using a real welding gun. We performed the user study with 24 novice welders to evaluate the usability of the training tool and demonstrate the user engagement and effectiveness of the system to transfer skills into the real-world environment. Each user study session was divided into two activities, the non-welding activity followed by the welding activity. For the first activity, users were randomly assigned to undergo either video or VR training in preparation of performing a wire change on a real welding machine. From the user study results, we found that the VR training enhanced students' performance and user experience as compared to 2D video-based training methods. Following next was the welding activity, which was divided into two subtasks, one involving the user performing virtual welding using a real welding gun and the other using the Oculus controllers. It was observed that participants' overall performance and accuracy were improved with the use of the welding gun when compared to the use of the Oculus controllers. As a scope of future work, we plan to improve the existing 3D mount to trigger the virtual welding when pressing the trigger button on the real welding gun. It would also be interesting to extend the haptic perception from the welding gun to include forces and vibrotactile sensations and develop experiments to compare with different results. We plan to build on the existing prototype in future to include the remaining exercises associated with the learning modules. After checking that the system provides acceptable results in the short term, we are planning to conduct a study to check whether long-term exposure of the virtual simulator would lead to the psychomotor skill development for welding. We have presented VR Well Learner, the system design of a high-fidelity, holistic, and low-cost virtual reality-based training system that could be easily adapted and distributed to increase training availability. We actively consulted with welding training experts and gathered their feedback to develop the learning objectives by following the backward design model from the approach of learning sciences. We structured the learning modules of VR Well Learner by following a set of design guidelines. The user study on 24 welding novices demonstrated how the learning modules in our system can help novices learn welding concepts in a guided format. The study results confirm the usability of the system. First, we found that the system features are easy to use and are effective in transferring skills to the real-world environment. Second, our proposed alternative for visual haptic guidance with a real welding gun provided a more realistic learning experience for novice welders to practice skills during virtual welding while improving performance. Thanks for listening. In case of any questions, please reach out to me.